All right, you can go.
Have you gotten it?
Good afternoon, superstars. Good afternoon, superstars. And I want to believe that we're going to have a very wonderful time together again today. For those of you that were not in class yesterday, we actually started organic chemistry. I just introduced you guys to organic chemistry, and we narrowed it down to alkanes because I told you that the foundation of all organic compounds it's actually arcane. So if arcane is not properly taught, you have problem with other classes of organic compounds such as alkenes, alkynes, alkanols, alkanoic acid, esters, even polymers and carbohydrates and stuff like that. So, and that is the reason why I took my time to just start. But unfortunately, because we didn't have enough time, so I would like you to please sign up so that by next week, when we start the proper class on Monday, all right, so which is 12th of January, you'll be able to benefit from that. So today, we'll be introducing you to another aspect of chemistry, which is usually every year the question comes from this, and that is redox equations. Okay, so we're talking about redox reactions. Okay, so this is another aspect of chemistry in JAMB that is very, very, very important. And you just must know this because it's very, very important. There is no year you open any year, you will not see questions on redox reactions. There are major and minor topics. But our idea is to cover everything and make you to understand every concept that you need to learn. So this is why we're going into redox reactions in this class today. All right. And I want to believe that you have your pen and paper and your notes pad ready for the class because I'm going to be giving you a lot of questions. We'll pick all the examples. Then we'll go into jump questions and see how far you can actually go with that. So in this class, you learn how to write ionic equations. Then you split ionic equation into oxidation half and reduction half. Then you would now learn the proper balancing of redox equations. Most students find this very difficult, but I can tell you our job at Tutoria is to simplify the difficult topics, to break it down into bits and in such a way that it's going to make all sense to you. So please, if you have phobia for chemistry, like chemistry is not your friend, you just like, I hate chemistry. This is the moment for you to love chemistry. Chemistry is not difficult. It's very easy. Like I always say, it's the easiest subject. But what you have to do in your own part, you just have to find the right coach, which you have just done. All right. With Dr. John by your side, you can always be at the end of the curve. So what are redox reactions? Redox reaction is a reaction which involves oxidation and reduction taking place at the same time. Oxidation and reduction taking place at the same time. That means the oxidation is taking place, reduction is also taking place. Let me just give you an example. If you credit another account, your if your friend's account with your account, let's say you send money, let's say 100,000. As you send the money out, the your friend's account will be increased while your own account will be decreased. So that is happening at the same time. Well, let me just even use another game that just like table tennis that may not end in draw, okay? Because there are some games that can end in draw. Okay, so let's say you're playing table tennis. As you start, somebody's already winning and somebody's already losing. Okay, so and it's happening at the same time. So redox reactions involves two opposite but complementary reactions taking place at the same time. And those two reactions are oxidation and reduction. Okay, oxidation and reductions are taking place at the same time. Okay, so that is what you need to know. Okay, the reaction is oxidation, another reaction is reduction. Both are taking place at the same time. So, and that is what you need to know. Okay, so let's get into it and see how we can balance the equation that involves this oxidation and reduction. Then from there, you'll be able to learn how to go about it. Okay, so let's quickly get it done. Let's get it done so that we can move now. All right. We want to learn how to balance chemical equation now using the redox. Okay, so let me pick this. Okay, so let's move. Okay, so the first equation is we want to write the ionic equation. Okay, for this particular reaction, we want to write the ionic equation between zinc metal and aqueous copper sulfate. We want to use this to explain oxidation reduction. We're writing the ionic equation between zinc metal and aqueous copper sulfate. Okay, so let's say this is zinc. I hope you can see that very clearly. Plus copper sulfate, that is copper 2 tetraoxosulfate 6. You learn how to write the formula of a compound in SS1, and when the class starts next week, we are not going to assume anything. We're going to treat you from the scratch so that you know how to write the equation. So you're going to have zinc sulfate, that is zinc tetrasulfate 6 plus copper. This is a displacement reaction, but that's not where we're going. We want to learn how to write the ionic equation for this reaction. Okay, if you look at zinc, it's an element. Okay, so you don't have to split it because you can't split an element. So you write it as zinc. But for compound, two ions come together. Okay, and these are zinc 2 plus, copper 2 plus, and SO4 2 minus. Okay, if you don't know how to write formula, you can watch one of my videos on all my social media platforms to be able to learn how to write formula. So you'll be able to know that copper sulfate you can split it into these ions. Okay, so you are going to do this with me. So how do we split zinc sulfate? So it's the same thing, zinc 2 plus and SO4 2 minus. Then we have copper. Okay, so that is okay. Now, when you look at this, you will see that there are some species that are the same on both sides of the equation. So look at this. The first side of the equation we call reactant side is before we have zinc and this copper sulfate there. So you will see that this particular one occurs on both sides of the equation. We call it spectator ions. They are not actually really, they are just watching. And then we have what is left as zinc plus copper 2 plus. We give you zinc 2 plus copper. Okay, so this is the ionic equation. Okay, we have cancelled out the spectator ions, the ions that are not actually participating. They are both sides, in both sides of the reaction, they're the same. So this is what we call ionic equation. What did I do? I was able to split the compounds, which are ionic compounds, into ions. Then I cancel out. All right, but before we know which one is oxidation, which one is reduction, I can just tell you this. Look at the zinc, go to this, zinc 2 plus. Let me just do it that way so that you see it. Zinc going to zinc 2 plus. What is the oxidation state of zinc? Any uncombined element is 0. All right. Then from the product side, you can see the stuff there is +2. So that shows that the oxidation state it changes from 0 to +2. That is an increase. Oxidation state of zinc changes from 0 to +2. That is an increase. So whenever you have an increase in oxidation state, that is oxidation. Okay, so this is oxidation. That means zinc has been oxidized to zinc 2 plus. That's just what it means. Okay, if you look at copper, Okay, if you look at copper from there, let me clear this. Okay, let me use this part up there. Okay, if you look at copper, you will see that copper changes from +2 to this copper. So I can write it like this: Cu2 plus to Cu. Okay, so that means the oxidation state changes from +2 to 0. This has reduced in oxidation state. I've told you that whenever you have an element in uncombined form, you can see there is no charge there. So that is a 0 for the oxidation state. So that shows that oxidation state has changed from +2 to 0. It has reduced. That means copper 2 plus has undergone reduction. Oxidation state has reduced. So that is reduction. So zinc is oxidized, copper is reduced. So we can say that this zinc, because it has oxidized, so that shows that copper sulfate is oxidizing agent. All right, I've told you that the oxidation state of zinc changes from 0 to +2. Whenever there is increase, that is oxidation. Okay, so that shows that copper sulfate is the oxidizing agent which oxidizes zinc. Now, if you look at copper here, has changed from +2 to 0. That shows that it has been reduced. It shows that zinc is the reducing agent. So in a redox reaction, we have both oxidizing agent, which oxidizes the next substance, while we also have reducing agent, which reduces the cell sulfur. So this is just the first example. We might have to see more example to be able to move forward. Okay, so let's see the second one. Okay, we can look at this reaction taking place there. That is the reaction between um, magnesium and HCl. I hope you can see that clearly. So that's the reaction between magnesium. Magnesium, just like we did for zinc, is Mg. Can you see that? Okay, we add with HCl. Now, how do we form hydrochloric acid? It formed from two elements. One is hydrogen, okay, another one is chlorine. So this has a valency of plus, this has minus. All right. So I've told you, if you want to know how to write the formula of a compound so that you're able to split ions, watch one of my videos. But we have two there, so that shows that this two goes for this, and it also goes for that. Okay, so that means we have two hydrogen ions and we also have two chloride ions there. So now let's split magnesium chloride also into ions, and let's see how we're going to do that. All right, magnesium has the valency of 2 plus. Okay, some of you be wondering, like, how do you get 2 plus? All right, so please just sign up and stay with me so that you can learn more. The valency of chlorine is always -1. Okay, but if you look at this, we have two of it there. We simply put it here. All right, the two that you see there, I don't know if you have problem with writing formula, is going to constitute a lot of problem, and that's the reason why we have to learn how to do it. And I'm going to be taking you right from the scratch. Some of you have problem with chemistry because of the foundation. Okay, I just bring it here. So magnesium is 2 plus, chlorine is minus. When they cross this, it forms MgCl2. That's what you're seeing there. So that shows that it has one Mg ion and also two chloride ions, and that's what I've just done. So you put the two there. Then hydrogen is just an element. We don't split an element, although it's a molecule there, so that is two. All right, the next question is, what are the ions that are the same on both sides of the equation? So we just see that is 2Cl minus. Can you see that? So we cancel it out. So we are left with Mg again plus 2H plus. Okay, we'll give you Mg2 plus H2. Okay, so this is the ionic equation. It's that simple. But if you want to look at it again, we can combine this like that and move this one to this way. Okay, I hope you've seen that clearly. Let me pick black ink so that at least we'll be able to know that. Okay, so magnesium changes again from Mg to Mg2 plus. What does that tell you? It shows that Magnesium again has moved from a zero oxidation state to plus 2. All right, it has increased in oxidation state. This is also an oxidation half equation. Okay, this is an oxidation because the oxidation number of magnesium has increased from 0 to 2. Anytime there is increase in oxidation state, that shows oxidation. When there is reduction, I mean the oxidation number reduces, that is reduction. Of course, if you have found out that one is oxidation, of course the second half will be reduction. It's very simple. It's just like Chelsea is playing Man U and they say it's 2-1 and say, okay, who had two? You say it's Chelsea and you also ask who has one. All right, so of course you shouldn't answer that person because of course it's going to be the next team. So if this is oxidation, the next is reduction. But I'm telling you why it's reduction, because hydrogen moves from plus to H2. Okay, if you look at H plus to H2, you will see that it is plus 1 to 0. Okay, so let me look at it from here. Let me put it here properly. H plus to H2. Although we have this one here to make, it just means that we have H plus, we also have H plus. We have so many thousand of it and it produces H2. So you can see that it moves from plus 1 to anything that is not charged, that is alone, is 0. Okay, so this is a reduction in oxidation number. So when there is reduction, it means is a reduction half equation. Okay, so the other one is oxidation. So that is what it means. So if I may ask you, which species is oxidized? So it's magnesium. Okay, because it moves from 0 to plus 2. So magnesium is the one that is oxidized because it moved from 0 to plus 2, while hydrogen is reduced. Let's see the third example. Okay, and I want you to try this first before I put the answer there for you. Okay, I want you to see the next one. Let me see whether it's difficult. Okay, so write the ionic equation between fluorine and potassium bromide. Okay, we have written the equation actually. All right, it's just to now learn how to split it. Okay, so I want you to try. Just try as you're walking that way. I'm waiting for you. Just try. Let's see how you're going to write the ionic equation. Within just 1 minute, it should be done. All right, so I will provide the answer now, and you will see whether you got that correctly. So it's when you learn from this principle that you can attempt questions. Remember, we're discussing redox reaction, and we said redox reaction is like it has a twin reaction taking place. That is oxidation and reduction. Two are opposite but complementary reactions because they are happening at the same time, and one is not happening in the absence of the other. Okay, so that's why I say they are opposite but complementary. All right, reaction taking place at the same time. Okay, so let's see. I want to provide solution to this now. Very easy. F2, all right, because it's fluorine, one element, you can't split it. If you are inviting two people to your birthday party, you say, oh, my two guys are coming. All right, if it is one person is coming. You can't split one person and say half is coming. Okay, you'll be killing the person. So we don't want to kill chlorine or fluorine, and that's why we are not splitting it in ionic equation. So but this is potassium bromide. It's an ionic compound. That means two opposite ions come together to form that compound. So we're going to split it, okay, into their ions. Okay, so that is K plus and Br minus. The problem that students usually have, how do you know, Dr. Jan, that this is K plus and this is Br minus? It's an entire topic entirely, which we're going to use the electron configuration to derive the valencies, at least of the first 20 elements. All right, and all the group 7 elements, bromine, all the fluorine, chlorine, bromine, everything, they have -1 as their charge. So we'll just take it this way so that at least you can learn the principle of this ion equation. So 2 goes for both. That's what it means. Since KBr has both K plus and Br minus, that 2 goes for both. So I can do that here. I split this one too. It's very simple. And 2F minus. Okay, so I don't think this one should be difficult. Okay, so let's see. Br2 is also an element that's called bromine, so we don't split it. Okay, Remember, I've told you we don't split um, elements, so we only split ionic compound. So the next step you may want to look at is which of them, of this species, which of them is can be regarded as the spectator ions, that ions that are just the same on both sides of the equation. So can you look at it? Have you seen it? Okay, let's see. Uh, check, check, check. Which one are the same? You will see that K plus and these are the same. Just cancel it that way. Then write whatever that is left. F2 plus 2Br minus, okay, will give you 2F minus plus B out. All right. So I can as well split these two into two. I want to know the species that is oxidized and the one that is reduced. So let me pull this way. All right. It's just like BR goes to BR and all that. I didn't do any special thing there. So we have F2 go to 2F minus. Okay. Now look at this. Anything that is not charged, it's zero. Okay. This one is like minus one, although we have two of it, two of minus one, making the total charge of minus two, but F itself is from zero to minus one. So is this an increase or a decrease? All right, check, check. Is this from zero to minus one? It's a, okay, so that means this is a reduction. So don't think reduction, oxidation is always written first or whatever. So whatever the equation is given to you, work it out. Why is it a reduction? Because fluorine reduces from zero to minus one. How do I know it's zero? Because it's just fluorine alone, uncombined state, only one element without charge, uncombined. But the F minus, it has combined with other elements, and that's why we cancelled stuff out to arrive at that. So we have 0 to minus 1. So that is reduction. Okay. And you can tell me why is the other part oxidation? If I may tell you, we are talking about in terms of electron transfer. So we have Br minus to Br minus to Br2. Why is this an oxidation half? We have 2 here, all right, to balance the atom. So this moves like from minus 1. Remember, we have 2 of it. Don't always say the charge on Br. We cannot get Br2 minus. So that's why I'm telling you that it's just this. The total charge is now we have 2 Br minus. We have 1 Br minus, another Br minus, making 2 of it. So we went from minus 1 to 0. So this is an increase in oxidation state. This is the minus 1. This is 0 because it's not charged. So this is an increase, which makes it oxidation. Okay. So this is an oxidation half equation. So that is how to actually split the ionic equation into oxidation and reduction half. Oxidation and reduction half. So if I may now tell you which one is the oxidizing agent, which is the reducing agent. Remember we said fluorine is reduced. If fluorine is reduced because it moved from 0 to minus 1, that shows that KBr is the reducing agent because it has reduced fluorine. All right. How do I know? Fluorine moves from 0 to minus 1. That's the reduction. So KBr. Remember, we only have reducing agent and oxidizing agent at the reactant side. Reactant side of the equations are the ones before the arrow. Okay. So because in the you tell me, you will see that they will say which of the following is a reducing agent. They will put F2 as option A, then KBr as B, then KF as C, and this as D. Just cancel this. It can never be product because when we are talking about oxidizing agent and reducing agent, we are talking about reactant. That information is very important. So when they say which one is oxidizing agent, which one is reducing agent, you're only talking about reactant. This species coming together before the arrow. You can never have oxidizing agent in the product side and the reactant side. So we are talking about it as what are the things reacting. Okay, if you are considering the reaction is reversible, then you say the products are now reacting. So those are the reactants or reacting species in the equation. So I believe that this is simple enough for you to understand. The only problem you might be having, which I'm aware, is how will you write the formula correctly and how will you split a compound into correct ions. Because if you don't do that correctly, that would be a very difficult situation. And you may have to join my class. Sign up, please. Let's stay together. Let me teach you chemistry principles, because one of the best thing you can do for yourself is to find the right coach, which is Dr. Jam, and I'm going to take you through, hold you by the hand, and make sure that you understand all these concepts. They are very, very simple. So let's do this ionic equation. I will now just possibly provide one redox equation. Then once we are done, we go into the past questions and see whether you can apply most of these things that we are talking about. Now, write the ionic equation between sulfuric acid and sodium hydroxide solution. Okay, the bottle, the containers you're seeing there are the container. If you use the chemistry lab, you'll see this on the shelf. So you can react together. This kind of reaction is called neutralization reaction, because that's not where we're going. The reaction between an acid and a base to form salt and water. Okay, but we want to split this into ions now, and we now cut out these spectator ions that are the same on both sides of the equation. So now, what made me to give this as one of the examples? Because we have another substance that we don't usually split easily. So we're going to see that. So I'll do this with you. All right. So how do we form H2SO4, which is sulfuric acid? We form it by the hydrogen ion and SO4 ion. So that is it. This is a radical. Okay, I'll be taking some topics specially about how to handle this. So just know that I'm splitting the hydrogen and sulfuric acid, but we have two of hydrogen. Can you see how I did the splitting? So don't make that mistake. Okay, don't make that mistake. We have two of hydrogen ions with SO4, and that's why the balance of charges, it forms neutral H2SO4. Let's see whether you can try how to split sodium hydroxide. Sodium is an element also, but this is a radical group of atoms. They have the charge -1. The more you use it, just like you can recognize your brother, because you know this is my brother, I see you every day, and that's actually why you recognize him. If your brother was born in another country, I've never taken any video call or whatever, you won't recognize it. So OH has a charge of -1. Okay, I'm going to make sure that I record a video for you to actually see free of charge, for you to see how to get the charge for this. But importantly, make sure you sign up, so that at least we always be in the same class together. So this is sodium hydroxide. Sodium has a charge of plus. Then OH is a group of atoms, okay? Group of two atoms, they have the charge -1. Let me just give you this so that you can know. What's the charge of oxygen is -2. The charge of, that's valency of hydrogen, is +1. When you add it together, you get -1. That's how we get it. I will have a class entirely for that, so that we learn from that, okay? So let's just take it this way. So sodium hydroxide is that, and I hope you're enjoying the class. So please get the work done by yourself. Let's be doing the same thing I'm doing. So, but we have two of it. So two goes there and two goes there, because we have two, that two goes for both. That's how to split that. Then we are splitting this also, which is sodium and SO4, 2 minus. Okay, now that sodium plus is there, but if you look at the Na2, so it's only sodium that has two of it there, just like we did for hydrogen. SO4 is SO4. Then we don't split H2O because it's poorly ionized, except I add something to water like acid or another ionic compound, because you can split it. So just take it now that we don't split an element, we don't split water. I will hold the third one, which is later we're going to have those examples. So please don't forget to do that. Okay, so let's now look at this. What can we cancel? What are the things that are the same on both sides of the equation? You can see that it's not only one thing now. So, and that's the reason why I gave this example, because you're a JAMB student, supposed to be doing well with chemistry now. So SO4, I can see it, they're the same on both sides. Then I also see Na2 plus. Can you see? So what is left? We have 2H plus 2OH minus. That's just what is left. Then we have, all right, two. Remember, two water is there. Okay. So we have 2H2. Okay. So if I call the two, like factorizing two out, it's still the same thing as this. OH minus will give you 2H2O. Okay, so this is the ionic equation for this neutralization reaction. And that is very, very important. And you have to learn that. Okay, you just have to know that it is very, very simple. And you must know that. Now look at it. You by looking at it, you will see that the first challenge you may have is how to split compound into correct ions. Okay, you were taught possibly around in year 11, like SS2, but we are going to go deep into it from next week. So if you want to learn more of chemistry, please just like let's have more time together. I'm excited about this, being your teacher, okay? Because I'm going to take you to where you need to be. Some of you think something is like wrong somewhere. I don't just get chemistry. Chemistry is very simple. It's this simple. Just cut out and get you an equation. So we're going to give one example about the redox equation. Redox is a bit complex, and I want to start from here. Okay, the question says balance the redox equation between two ions and acidified potassium tetraoxomanganate 7, and that is what we have there. Okay, this equation is already in ionic, but we have not balanced it. Okay, why is it not balanced? If you look at the reactant side, we have oxygen. At the product side, there is no oxygen. Of course, that means something is missing. So this is the kind of redox equations that involves both oxidation and reduction half. Okay, and we have to learn how to do that. Okay, we're going to split it into two, just like we're doing after ionic equation. We want to know the oxidizing agent and reducing agent. So, but just sit tight now so that we can learn every step involved here. Once you understand this, I can tell you open past questions into oxidation and reduction. You will see that it's just so simple. Things that are difficult for you is now looking very simple. Okay, so can we go? Can we go now? Let's start. Okay. All right. So the first thing you may want to do is to split it like this. Some will say, how do I know where I'm going? It's just very simple. You can see they look alike, Mn, Mn, Fe, Fe. So I can pick Fe and Fe first. Fe 2 plus, can you see that? Goes to Fe plus. Okay, that's what I want to do first. Okay, I don't know. Now, if I may ask you, is this oxidation or reduction? Okay, is this oxidation or reduction? We have done that before now, so you should be able to tell me, is this oxidation or reduction? How will you know? Let's see, what's the oxidation state of Fe2 plus? It's plus 2. Then what is the oxidation state of Fe3 plus? It's plus 3. You can see the charge here. That is what is that charge that they are carrying? If it is 0, you write it there. That means you won't see any charge, but this is plus 2 to plus 3. Now, something changes from plus 2 to plus 3. Is that an increase? The answer is yes. And I've told you, please write it in your notes if you didn't write that when I told you that. Whenever there is increase in oxidation state, that is oxidation. So that shows that this is our oxidation half equation. Just like I've told you that in redox reactions, we have both oxidation half and reduction half. Putting the two together is what makes it balanced. Okay, so remember, this is not ionic equation. It's already written ionic. They said we should balance the equation, and I'm going to show you so many past questions and the questions that we have there. So we have Fe plus 2 plus going into Fe3 plus. Okay, so that's great. It's oxidation half because there is increase in oxidation state. So, but in terms of charge, it is not balanced. Okay, it is not balanced. We have plus 2 here, we have plus 3 here. So the next thing you have to know, and you have to note, that whenever we want to balance the charge in redox equation, we use electron. I will say that again for those of you that didn't listen to that. Whenever we want to balance the ionic equation, we want to balance the charges, we use electron, okay? And we add electron, we may add it to the reactant side or to the product side, depending on what happens. Now, let's look at this. Electrons are negatively charged. So if you are putting negative one side, it's like subtracting from it. So that's what I'm saying. So I'm going to do a particular intentional error here, and I want you to watch carefully. I just don't know where to add because that's the problem that most students face. They don't know exactly what to add. Okay, so let's say I want to add electron to the reactant side. You know what it means? If I want to add electron to the reactant side, this is what it means. Okay, we have this. You see, Fe. I'm writing in blue so that you can see that. I will now add electron. I will say Fe3 plus. Look at this. So now we have plus 2 here, we have minus 1. At the product side, we have plus 3. So 2 minus 1 is minus 1, and this is plus 3. You can see that the reactant side, the product side, minus 1 plus 3. They are not equal. So that shows that it's likely not to be there. Okay, of course, it can be there. So, and that is what you have to understand. Okay, okay. So let me now put it here. Let me put it at the product side. I'm cleaning up this. Okay, that is, I just showed you that when you put it that way, because it's a lot for some students to just know that where will I add these electrons? They'll start crying. All right, I have a lot of baby jam students. Just cry, please don't stress me with this. But when they learn it, they'll now say, oh, sir, oh, I don't know, I've been struggling for years. All right, so we are adding electron to this place. Okay, how do I know? Plus 2 plus 3. Then you add 1. It's like you're adding 1 electron. So at the end of the day, we have plus 2 plus 2. Okay, so that shows this balance. So this is the balanced oxidation half. All right. Then if you look at this particular slide, there is a part I said oil rig. Don't let me even go back. Let me just write there. Oil rig. Can you say it? Oil rig. We're running. Oh, this is okay. So let's just manage our time very well so that at least we can see this. It's important to learn this, or I teach you this, because it gives a lot of trouble, a lot of stress to my students, and I don't want you with stress. So I pride myself as a friendly chemistry teacher. Okay, I'm just friendly and patient. Okay, just keep saying it, keep saying it. I'll keep until you understand it. Okay, oil rig is very simple. What it means that oxidation is loss of electron. Okay, and look at this. This is Fe. You are losing electron. Electron is at the product side, so that means it gives out electron. So oxidation is lost. I've told you two reasons now why this reaction is oxidation. Number one, there is increase in oxidation number from plus 2 to plus 3. Number two, electron is at the outer side. That means giving it out. If I add it to this place, that means is gaining it. But in oxidation, we say oxidation is lost. That is oil. So of course, what do you think reduction will be? IG, what do you think that one will be? Okay, you can guess. If oxidation is lost, that means reduction is gain of electron. So let's now see where electron will be in the reduction part. Remember, I circled this. That is our equation 1. This is our equation 1. Okay, Fe2 plus to Fe3 plus this. Okay, so I would put it properly now here so that we can put that. Sorry. Okay, let me go up there. Okay, so let's stay here. So we have agreed that we have Fe2 plus to Fe3 plus electron as our equation 1, which is the oxidation half. Okay, so for reduction half, from the equation they gave us MnO4 minus to Mn2 plus. That is what is there. If you look at it, that's what is there. Can you see? That is that. We move from MnO4 to Mn2 plus. So what do we do? Okay, time is going. So now, this is what we want to balance now. We are done with this one. So once we balance that, we just bring them together. MnO4 minus to Mn2 plus. What is important that you learn this? Okay. Now, look at this. There is oxygen here, but there is no oxygen at the product side. So what you do is just you rewrite it MnO4 minus plus Mn2 plus. So you may want to say, oh, let me put oxygen here. So you just put oxygen. Okay, but it's going to be four of it. But now we don't just put oxygen that way because oxygen cannot even stay this way. So we use water. Okay, H2O. Okay, so that means I added four H2O so that I'll have four O that way. All right. So that means whenever I want to balance for oxygen, we make use of the water molecules. Please write it. That's the third point I'm giving to you. That is a secret that every child should work with. Once you work with it, then it becomes very easy. So that is 4H2O. So that now say MnO4 minus, we give you Mn2 plus. I'm writing it again plus 4H2O. Okay. So the reason why I added 4H2O is because I have four oxygen here. If I have seven oxygen here, you're going to have seven H2O. That is it. But we have created another problem, and I want somebody to please be able to put it in the right perspective. What problem have I created? I've added hydrogen to the product side. So, and there is no hydrogen here. So what you do is you simply MnO4 minus plus you now add the hydrogen. How many hydrogen have I added? 8. So we use H plus because it's in acidic. We now have 8 of it. Okay, why is that? Because I have 4H2O. So I had 8H from there. So we now have Mn2 plus 4H2O. You can see that it's looking like it's complex, but it's not because we are working step by step. The next thing is you balance the charge. Okay, what is the charge on the Mn minus? The MnO4 minus. This is minus 1. Look at this charge here. We have 8 of hydrogen there. That is 8 into plus 1. Okay, 8 of it. So minus 1 plus 8 will give you plus 7. Okay, then the whole side of this product side, we only have plus 2, and that is what you're seeing there, Mn2 plus. There is no charge on water because it's neutral. So we have plus 7 here, we have plus 2 here. So that shows that we are going to add electron to this side. We're going to subtract 5 from here. So it's like adding 5 electrons. Okay. 7 minus 5 will give us 2, 2. So that is lovely. So and that one will give us back our the second equation that we're looking for. So let me just write it. MnO4 minus. We said we added H plus. I'm adding 5 electrons here to give me Mn2 plus 4H2O, right? So if you look at it, everything is balanced now. Minus 1 plus 7 plus 5 will give you plus 2 and all that. So this is our equation 2. Okay, which is reduction. You can see that now that reduction is gain. We add electron to the reactant side. So oxidation is lost. We add electron to the outer side. So we have just few minutes to the end of the class, but I'm very happy that we should be able to finish this. So equation 1 is this, which we have written before, Fn2 Fe3 plus electron. Okay, that is equation 1. So how do we combine the two together? When you give money to your friend, the money does not fall on the floor. Even if it falls on the floor, your friend takes it. That means what you give out is what your friend receives. So the same thing with this, you are going to apply that now. And listen very well. We have 5 electrons being gained by the equation 2, okay, being added. We have 1 electron to that. So what you're going to do is that you just multiply this by 5. You multiply this by 1. How do I get that one? This is 1E, this is 5E. You switch it so that the E can be the same. So let's do that. We have 5Fe2 plus. If this is what we're going to do, it's really worth it. 5Fe3 plus 5 electrons. Okay, that is the balanced equation 1. If you multiply 1 throughout that, you're going to have MnO4 minus. Some people will be like, how did we get here? You can see that it looks complex now, but it's very easy if you're following like the way we are treating it. Don't get distracted. Okay, I just multiply 1. Okay, have you seen that? So this is equation 1, this is equation 2 now. Remember, all we need to do now is just to combine these two. Okay, we write all the stuff we have at the reactant side. This is reactant, these are the reactant part. Then we write the product too. So then we combine it, and that is the answer for that. Okay, so let's see Now I'm picking this one. I'll be crossing. Let me pick red pen so that we can cross that. Okay, so Mn, I'm picking this MnO4 plus. So MnO4 minus. So I'm done with this. Then I want to pick 5Fe2 plus. Remember that I'm adding everything in the reactant side together. I'm going to make more videos on this so that you can see how easy it is. 8H plus, can you see? Plus 5 electrons. Okay, those are the things in the reactant side. Okay, the product side, those ones written in blue. So I start with Mn2 plus. I'm combining the two equations. Okay, plus 5Fe3 plus. Are you seeing that? Plus 4H2O plus 5 electrons. Okay, this is H2. So once you cancel this electron, that both sides, but they are equal. So whatever that is left is the ionic equation. So, and that is what most students really find. Some students just believe that they can't get it, and it's this simple. But remember, this is example one. If you don't know it, it's still okay for you to feel that way. But by the time I finish the example two, you will like, wow, then I can now understand. Example three, you become a pro. So what you need to do just now, stay with me, sign up and do that. Okay. So I'm not going to do this example. Let me go to some past questions and see some of the things in 1 minute. Okay. The question says here, this one was in year 2022, number 18. He said, in the reaction above, the substance that is being reduced is, okay, now the substance that is being reduced is, the substance that is being reduced is what? Okay, okay, so which substance is being reduced? That is the last thing that we are going to look at. Then, all right, so look at zinc, is 0. Now is zinc 2 plus here. So zinc is being oxidized. Remember that that can only happen here. So that's what I'm telling you, that you are going to cancel anything that is zinc sulfate because they are the product side, copper. So when we're talking about something oxidized, something being reduced, it's going to be the reactant side, and that is it. So since zinc is oxidized, that shows that it's copper sulfate that is being reduced. The answer is C. That is the speed and accuracy that comes with JAMB question. So it's very simple, but you have to stay with me to do so many questions. So our time is up, all right? And I want to believe that you are able to learn one or two things, okay? And my joy will be to actually meet you again, honestly. I wish I could just use magnet and bring you right here in front of me. So thank you very much. And I believe that we're going to have a very beautiful time together starting from next week. Although we still have one class tomorrow. All right. Thank you very much. Follow me in all these social media handles and make sure you ask me, Dr. Jam, make video on this, and I'll be glad to do that. Thank you very much, and enjoy the rest of the classes.